And y'all, 8.1 deals with polynomial functions. Whoops, let me get that camera fixed a little bit more. All right. And so y'all, the main thing is a polynomial just means it's an expression made up of many terms. It could be a one-term polynomial that we call a monomial, and two terms we call a binomial, three terms we call a trinomial. But instead of naming everything that's higher, we just call them polynomials, okay? So poly means many. So it's got many terms. So we're going to look at end behavior. Of a polynomial function. And what we mean by end behavior is as our graphs go out towards negative infinity and positive infinity in the x directions, graphs have a similar tendency on what they look like as the graphs get bigger and bigger. So I'm going to show you what I'm talking about on that. So let me go to y equals, I'm going to clear this. And I'm just going to show you just the x squared graph. So when we had the x squared graph, I want y'all to watch what happens. It's going to look like a parabola. Now, notice that looks like a parabola. Now let me go and change that exponent from a 2 to a 4. So now I'm going to graph an x to the 4. But y'all notice, it basically is the same graph. The only difference is in the middle here, it's got a few more turns than the regular parabola. The parabola just came down and went up, to where this would actually come down and have a little hump or two and then go back up. So would that work with a 6? So let's see, let's put a 6 here. So now I'm going to graph x to the 6th, and I just want you to see what happens to the graph. It still looks like a parabola, although it'll have a lot more terms in the middle there, okay? Now, if we were to put a negative in front of that and change my exponent to a 2 and graph that, remember this is going to flip it over. It's also true if that's a 4. It'll still flip it over and have the same look. So now, what if these are odd exponents? So let me clear that and do x to the 3rd. So I want you to look at x to the 3rd, and then we'll do x to the 5th. So x to the 3rd comes uphill, left to right. And remember, odd ones are symmetric to the origin there. So if I'm going to change that exponent from a 3 now to a 5 and graph that. But y'all look, it still goes uphill, left to right. So knowing that, we can come up with a chart to predict what the end behavior of these graphs will do. So we're going to make a chart. So across the top, we're going to have the degree. And the degree can be even, or the degree can be odd. Okay? So we're going to have even degrees and odd degrees. We're also going to compare the sign of the lead term. So the lead coefficient. And remember, coefficient just means it's the number in front. That lead coefficient can be positive or it can be negative. So we're going to break this into 4 types of graphs. So we seen a while ago when I graphed one of these and it had an even degree, And remember, the degree is just the highest exponent. Those graphs want to go uphill on both sides. Now, we leave a little space here because depending on the degree, there's going to be a lot of turns in here, okay? But in the big picture, both these graphs, if they're even, go uphill. And then remember, when I made that negative, it flipped it over so that both sides were going downhill. Now, I also showed you when it was odd, we had, say, a x to the 3 sitting here. When that first degree was even, this went uphill, left to right. And when I went back and inserted a negative in the front and graphed it, that makes it go downhill, left to right. Now remember, they're putting arrows on these sides of the graphs, but that just means the graph goes on forever, okay? All right, so let's see. Our questions, they're going to give us polynomials, and we got to determine what the end shape will look like, okay? What's going to happen to this graph if we did graph it? So this chart, I would keep handy for this whole chapter, okay? So determine the end behavior of the function. So for number one, they're giving us f of x equals negative square root of 2 x to the third plus 2x squared minus 5x plus 5. So the thing I'm going to look at, there's only two things I'm worried about on our chart. The degree, is it even or odd? And that lead coefficient, positive or negative. So let's find the degree first. The degree is equal to the highest exponent. The highest exponent here is a 3, so this is a degree 3, which is odd. So I know for sure the end behavior will be one of the right two in the odd column. Then the lead coefficient, well, the lead coefficient is a negative square root of 2, which is negative. So y'all, since my degree is odd, my lead coefficient is negative, I would choose the bottom right picture, and this graph will go downhill from left to right. So y'all, that's the trick on this. We just gotta figure out the degree, sign of the lead coefficient, pick one of our pictures and move on, okay? All right, so we're going to move to number 2. Oh, I'm trying to move this thing out of my way. All right, so for number 2 here, P of x equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 2. So I want to find my degree first, and then I'm going to find the lead coefficient so I can find what sign it's going to be. So our degree is the highest exponent, and y'all, the highest exponent is a 6. So that is a degree 6, which is even. So I know it's going to be one of my pictures in the first column. My lead coefficient is a negative pi. So they're just trying to throw you curveballs with the radicals and the pi, but it don't matter. We're just concerned with what sign it is, and this is definitely negative. So on a chart, if it was even and negative, it looks like it's going to go downhill on both sides. So y'all, this is not too bad on this little section here, because all you got to do is really just look at your charts and see what we get. And then they give you pictures to choose. So I just want y'all to see. So they're going to have a picture of each of the drawings, and you just want to pick one of them, okay? All righty, so this one has f of x equals negative 4.4 x to the fourth plus x to the sixth plus 0.5 x to the seventh. So if you want to, on this problem, if it would help you, I would rearrange this and get them in descending order. So what we mean by descending order is put all these terms in order from the highest exponent to the lowest. So I would have f of x equals 0.5 x to the seventh, and then that x to the sixth would be next, and then that minus 4.4 x to the fourth. Sometimes it's easier to find the degree and lead coefficient if you got them in the right order, okay? So here we go. We're going to find our degree and the lead coefficient. Because y'all, when they're out of order, remember the degree is still the highest exponent, which is going to be that 7, okay? But now that I got them in order, I can easily tell that my degree is a 7. And the lead coefficient is always the number in front of the highest exponent term. So the lead coefficient would actually be the 0.5. But y'all, a lot of times when they're out of order like this, y'all get the right degree, but then people will put negative 4.4 for the lead coefficient because it's first. But remember, lead coefficient is always the number in front of that term that has your degree. All right, now 0.5 is positive, and then we said the degree 7 was odd. So for odd degree and a positive lead coefficient, it should look like it's going uphill, left to right. All right, y'all, one more of these and then we can move on to new stuff. So this one has f of x equals 3 plus 1/3 x to the fourth minus 1/3 x to the third. So I'm going to do the same thing here. I'm going to rearrange this one because they're out of order. So the highest exponent is the 4, so I'm going to put my 1/3 x to the fourth. Next would be the 3, so that's going to give me negative 1/3 x to the third. And then at the end will be my plus 3. Y'all, these numbers that don't have variables, we call them constant terms because they never change, right? It's always going to be a 3 since it don't have no variable to be multiplied by, okay? All right, so I need my degree and my lead coefficient. So our degree this time is a 4, so that is even. Remember, the lead coefficient is the number in front of that x4, which is a 1/3, and that 1/3 is positive. So when it was an even degree, positive lead coefficient, both sides were pointing up. All right, I'm gonna let y'all write that for a second. Y'all begin to wonder, my test running people off. I'm down to 5 of y'all. Ooh, they're not that bad, are they? All right, y'all, moving on. So this next example, they want us use substitution to determine whether 4 is a 0 of the following. And they're giving me f of x equals x to the third minus 9x squared plus 10x plus 45. So here's the thing. If 4 is a 0 of this polynomial, then when I put 4 in for all these x's, my answer, y'all, has to be 0. To be a 0, you have to get a 0 for your answer. So they want us to find f of 4. And that's what they mean by using substitution. We're just going to put a 4 in for our x's. So that'll give me 4 to the third minus 9 times 4 squared plus 10 times 4 plus 45. And now I'm just going to hit my exponents first. So 4 to the third is 4 times 4 times 4, which should be 64, minus 9 times 4 squared. Well, 4 times 4 is 16. And then I'm just bringing everything down. Now, y'all can do more steps at once, but all I wanted to do on that step was hit these two exponents. Now I'll multiply where I need to, so I'm going to bring the 64 down, minus 9 times 16 is 144, plus 10 times 4 is 40, and then plus my 45. All right, so let's see what we get. 64 minus 144 gives me 80, plus 40, and then plus 45. I get a 5 out of that. So since my answer was not 0, that means no, 4 is not a 0. Okay, y'all, so you're just going to have one where they have you check a number, okay? All right, oh, not an example yet. All right, so new definitions. So remember, we said already that zeros were the numbers, or these were basically the solutions of the polynomial. So zeros, we said, were the solutions of the polynomial, and they were basically the same as the x-intercepts. So now a new word for y'all, multiplicity. And y'all, multiplicity is how many times a 0 occurs in a polynomial. So I'm going to sort of give you an example of what we mean by multiplicity, okay? So say I had something like f of x equals x squared plus 6x plus 9. Now, I'm going to solve this by finding the zeros. So to find my zeros, I would set it equal to 0. Now, y'all, what I'm going to do is factor this one, but if you don't know about factoring, you could always use the quadratic formula, okay? So I'm going to go straight into my parentheses. X squared means I got an X in the front of both of these. The last number is positive. Anytime the last number is positive, both of these factors have the same sign as the middle number, so they're both going to be positive. And then anytime the last one's positive, you want factors of the last number that add to get the middle number. So factors of 9 are 1 and 9, but those add to get 10. 3 times 3 is 9, and those do add to get 6. So I would put 3 and 3. So if you notice, x plus 3 times x plus 3 could really be written x plus 3 squared. Which means now this 2 is what I would call my multiplicity, because that factor happens twice, okay? So the multiplicity tells you how many times the factor happens. That way when you solve the factor for the 0, all you got to do is what? Subtract 3 and be done. But y'all look, if the factors are the same here, then that means that when you solve both of those, you're going to get -3. So on this problem, I would say 0 is -3. Multiplicity is 2. So it's how many times that happens, okay? All right, so I'm going to let y'all catch up a second. Oops. All righty, so you know the questions are about to hit us with some of this multiplicity on them, okay? So find the zeros of the polynomial function and state the multiplicities of each. All right, so that's, y'all, this one starts at about number 6. And it says f of x equals x squared minus 4 to the 4th power. So I'm going to tell you this, since I've only got one set of parentheses, the multiplicity will be the 4. Because that's how many times this parenthesis would be multiplied times itself if you were going to FOIL this out, okay? So thank God we ain't got to FOIL this. Now, to find the zeros, you're going to take x squared minus 4, and guess what? Set it equal to 0. All right, y'all, so 3 ways you could solve this. You could factor that. It's the difference of perfect squares. You'd get what, an x plus 2, x minus 2 if you factored it. You could use a quadratic formula. A would be 1, B would be 0 since you don't got an x term in the middle, and then C would be -4. And another way that you can solve stuff that I use when you just got an x squared term and a number, I'm going to solve it by taking square roots. So y'all watch this. To do that, you would add 4 to both sides. So I get an x squared equals a +4. And then to solve that, you would take a square root of both sides. Now, anytime you take a square root of a number in front of it, you got to put a plus or minus. Because 2 positives will make a positive answer. 2 negatives can multiply and make a positive answer. So here we go. Square root of x squared is x equal to plus or minus square root of 4 is 2. So that means +2 times +2 equals 4. -2 times -2 equals 4. So my zeros are x equals +2, x equals -2. Now, since both of them zeros came from this equation that was followed by the 4, both of these have a multiplicity of 4. Okay, so remember, outside exponents give you multiplicity. If there wasn't an exponent out here, guess what? We would treat that like a 1. Okay, so all them rules still hold for these. But y'all, it's not bad. The trick is just being able to solve for those zeros, okay? All right, so same thing. We're going to find the zeros and state multiplicity. Now, this one sort of broke out. They got f of x equals x to the 5th, x minus 5 squared, and then x plus 7. So the x plus 7 didn't have a number out here. So if we were to put a number there, it would be like a 1 there, okay? So notice I got 3 factors. All of them, here's the multiplicities, or the exponents. So notice a single variable don't have to be in parentheses because it ain't having nothing added and subtracted, okay? But you would still come down and take the variable x and set it equal to 0. Then you would take the x minus 5, set equal to 0. And then the x plus 7, set equal to 0. So guess what? This single variable, you can't do nothing to it. So a single variable like this, I don't care what the exponent is, its 0 will always be 0. Now this one here, you had x minus 5 equals 0, so we got to come in and add 5 to solve that one. So notice what they're doing. They're switching up. Some of these are quadratic, and some of these are just linear where you just add or subtract, okay? All right, then my third one, I'm going to subtract 7, and I get x equals a -7. So the way they did this, they said, hey, the smallest 0 so the smallest 0 I had, I got a 0, a 5, and a -7. The smallest 0 was -7 with multiplicity of, well, y'all, my 0, -7 came from this factor. It didn't have an exponent out here, so we put a 1, which means it has a multiplicity of 1. So next is the middle 0. Well, the middle zero, let's say I had a -7, then I would go to my 0 and then my 5. So the middle zero is 0 with multiplicity of, so how many times did the 0 happen? Well, it had an exponent of 5, so it's going to have a multiplicity of 5. And then finally, the largest 0 is, so my largest 0 was the 5, and it had a multiplicity of, so where's that exponent? 5 came from this factor. It had an exponent of 2, so it's got a multiplicity of 2. All right, so I'm going to do another one really similar to this one. All right, so I'm going to move over now. So this one is like number 8. Find the zeros and the multiplicity of each. All right, so find the zeros and the multiplicity of each. In this one, they're giving us f of x equals -5 times parentheses x minus 5 to the third, x plus 1 to the fourth, and then x squared. All right, so we know our multiplicities are going to be the 3, the 4, and the 2. I'm going to tell y'all, I got 3 factors here and not 4. I got an x minus 5, x plus 1, and the x. This -5 is not a factor because it's just a number. It does not have a variable, so we don't worry about constant terms like the -5 in front. Because y'all, it ain't got a variable, so I can't set it equal to 0, okay? So we would typically just cancel that factor out. But we would take the x minus 5, set it equal to 0. X plus 1, set it equal to 0. And then this x, set equal to 0. And once again, I can't do nothing to that when it's going to be 0 no matter what. So we can solve these two. So let's add 5 to the first one. The second one, we'll subtract 1. So I got my 3 zeros now. So the answer says the 0, 5 has multiplicity blank. And then it says blank is a 0 of multiplicity 4. The remaining 0 is blank and has multiplicity blank. So we must have done it right because 0, 5, here's the 0, 5. It has a multiplicity of, well, I got the 5 from this factor of x minus 5, which means it has a multiplicity of 3. Then it says blank is a 0 of multiplicity 4. Well, my multiplicity 4 was behind the x plus 1 parentheses, and the 0 I got from doing x plus 1 equals 0 was negative 1. So negative 1 is the 0 of multiplicity 4. Then it says the remaining 0 is blank. Well, the remaining 0 is 0, and the 0 had a multiplicity of 2. Okay, y'all, so that's the trick, is just sort of getting those little parentheses solved. Remember, if you got a single number without a variable, cancel it out. It's not going to have a 0, okay? Oh, okay, so I'm going to have to pull out more paper for this one. So let me turn this over. So y'all, number 9 is tricky. We're going to find the zeros of the function and their multiplicities. Multiplicities. Okay, close enough. All right, y'all, watch this. F of x equals x to the third minus 3x squared minus a x plus 3. So to find the zeros of this 4-term polynomial, I'm going to set this thing equal to 0. So I don't know how many of y'all just came out of our Foundations of Math class, but to solve this, I'm going to factor by grouping. Because you got 4 terms, you cannot factor it like a regular polynomial or binomial, okay? So factor by grouping, you would factor the first 2 terms together, and then you group the last 2 terms together. So I'm grouping it into 2 groups. So I'm going to factor out the GCF, and here I'm going to factor out the GCF. Now, here's an important note. The second GCF has the same sign as the third term. So that third term's negative. When I factor out the second GCF, it will be negative, okay? So the GCF is the greatest common factor. That means what these 2 terms have in common. And I want the largest factor they have in common. So notice, they don't have numbers in common because this one don't even have a number. They both have x's in common. But how many x's do they have in common? Well, this one has 3 and this one has 2. So the most that they can have in common is 2 x's. So what you would do is factor out those 2 x's out of that polynomial. Inside the parentheses, you divide both of these terms by the x squared. So if you had an x to the third divided by x to the second, 3 minus 2 would leave me 1x minus, if you had 3x squared and divided that by x squared, the x squareds would cancel and all that's left is a 3. So when you factor out a GCF, what's left in here cannot have anything else in common. So x squared would have basically been the GCF on that, okay? So now you go to the second two terms and factor out their GCF. Now we said here, second GCF has the same sign as the third term. That third term is negative. Second GCF will be negative. And look at this. I got an X and a 3. They don't have anything in common other than one thing, and that is a 1. So if you cannot find anything common between the two terms, you at least got to pull out a 1. And then remember, second parentheses, I'm going to take both of these and divide by that negative 1. So a negative X divided by negative 1 makes that a positive X. A positive 3 divided by that negative 1 makes that a negative 3. So my second GCF was negative 1. I divided both of them by negative 1. And all this is still equal to our 0. So what do y'all notice about that? If you do this correctly, these two parentheses got to match up, okay? So what I would do to finish factoring, since these parentheses match up, we're going to factor them out. And in parentheses, we put what's left. So if you take out an x minus 3 from this x squared term, all that's left is the x squared. And then if you had the negative 1 x minus 3 and took out the x minus 3, all that's left is the negative 1. All this still equal to 0. So y'all check this out. Parentheses match up, they become one factor. Everything else on the outside becomes the second factor. And notice, if you use to FOIL this, the x squared would still get multiplied by both of those like we had here, and the negative 1 would FOIL against both of those like we had there. All right, so at this point, we've got it factored down. I've got two factors. They don't have exponents here, so I would treat that like a 1 and that like a 1. So that all answers I get will have a multiplicity of 1. So then we do what? Set these equal to 0. Now look at this. One of these is sort of linear. One of them sort of quadratic because of the x squared. So this one I can solve by just adding 3. And I get x equals a positive 3. This one, since I just got an x squared term and a number, I'm going to do the square roots again. So I'm going to add 1. X squared equals 1. And then I'm going to take square roots. Now remember, I'm taking the square root of a number, so I need to use a plus or minus. All right, here we go. Square root of x squared is x. That's going to equal a plus or minus. Square root of 1 is 1. Now notice, let me show you a trick. Since the biggest exponent here was a 3, that means I got to get 3 zeros. So here we go. I got x equals 3 is a 0. X equals 1 is a 0, and x equals a negative 1 is a 0. So remember, that x squared stuff is giving you 2 of the zeros at once. And then all 3 of these, since we had exponent 1 here, exponent 1 here, all 3 have a multiplicity of 1. Now I got another one doing that factor by grouping after y'all write this one down, because it's probably been a while since y'all did this. And then I don't know who y'all had for foundations, whether they did it like this or not. All right, y'all, so I'm gonna do another one with the grouping so that y'all can get more practice on it. So this will be like number 10. So we're gonna find the zeros and the multiplicity. multiplicities. All right, so here we go. F of x equals 6x to the third minus x squared minus 384x plus 64. All right, so that's big numbers on this one. So the first thing, set this all equal to 0. And y'all, I'll tell you pretty much anything that's got higher exponents than a 1, you pretty much want to set them equal to 0 in this section. All right, so here we go. We're going to group the first two together and the second two together. Find GCFs of each. So 6x to the third, x squared. The most that they have in common is an x squared. So we're going to factor out the x squared and put everything else in parentheses. So that, once again, the x squared is my GCF. All right, 6x to the third divided by that x squared will leave you 6x. So nothing could change to 6, and then 3 minus 2 left me 1x, minus x squared divided by x squared is 1. So I know what's going to end up over here. If I do this right, I should get a 6x minus 1 in the second parentheses. All right, so the second GCF, we definitely know it's going to be negative like the third term. And then I'm going to try to do something. Let me see if this 384 will divide by that 64. Because I got to try to get a 1 there. Oh, and y'all, it does it 6 times. So the GCF will be a negative 64. And then in parentheses, we'll put what's left. 384 x's divided by 64. Well, I know that gave me 6x minus 64 divided by negative 64 is a negative 1. So look, my parentheses match up. Since my parentheses match up, 6x minus 1 comes out front. So both of these make this parenthesis, and then everything else, which is the x squared minus the 64, makes up the other factor. All this is equal to 0. Now, are you noticing? Once you got these parentheses, they become 1, and then all this GCF stuff is the other one, okay? So now, no exponents on these, so I would put a 1 there and a 1 there. Because there's nothing else I can do to factor it other than solve each of these factors. So I'm going to set 6x minus 1 equal to 0. And then I'm going to set x squared minus 64 equal to 0. All right, y'all, the first one's got 2 moves. You're first going to add 1 to both sides. And then to solve that, divide both sides by 6. So that my first 0 is going to be 1 over 6. Anytime you got numbers in front of the x like this, you're always going to get a fraction. Now remember, this x squared minus 64, since it's an x squared term in a number, I'm going to do the square roots to it. So I'm going to add 64. And then square root both sides. Remember, I need my plus or minus since I'm taking square root of a number. So here we go. Square root of x squared is x. This is going to give me a positive or negative. Square root of 64 is 8. So my zeros are going to be 1, 6, 8, negative 8, and all have multiplicity of And what was our exponents up here? We said those were ones. So all these have a multiplicity of 1. All right, so I'm going to do like 2 true, false, and then we'll do a break, okay? And then that'll finish out section 8.1. So true or false. If P of X equals X minus 3 to the 6, X plus 5 to the 9th, then the graph crosses the x-axis at 3, 0. So true or false? So they're giving you this point right here because that's an x-intercept, remember 3, 0? And we learned that x-intercepts are the same as zeros. So what I would do is take that x minus 3 and set it equal to 0. Solve that by adding 3. So you would get x equals 3. So since my 0 was 3, my x-intercept is 3, 0. That would definitely be true. All right, so, let me see. So what happens on this? Oh, these are different questions, y'all. Let me redo this number 11, okay? That's not what they're looking for this, so let me show you what they're doing. A graph, so I got caught ahead of myself. So what they want to know of this is it crossing the x-axis or is it tangent to the x-axis? A graph crosses the x-axis if the multiplicity is odd for that 0. So what we mean to cross it, it would actually go right through the x-axis and keep going, okay? A graph is tangent to the x-axis if the multiplicity is even for that 0. So what we mean by tangent, so if this was my x and y, a tangent would almost come down. It touches it, but it don't go through it, and it turns back up. So now that we know that, let me rewrite that number 11. So it says if P of X equals X minus 3 to the 6, and then X plus 5 to the 9th, then the graph crosses the x-axis at 3, 0. So I was mixed up, y'all. I was just...
Hey, could you go back for just a second?
On this one right here?
Yes.
Yeah. So what I did, I got mixed up on this problem and I was finding zeros and seeing if 3, 0 was actually a 0 of that. That's not what they wanted. They wanted to know if it crossed over the x-axis or if it was tangent to it. So That's the trick on this 11 and 12 is going to be, okay?
Okay, I got it. Thank you.
So to get the 3, 0, you would have had to use this factor, x minus 3 to the 6th. So it has a even multiplicity. So if it's even multiplicity, it's not actually crossing the x-axis, it's tangent to it. So this one is even multiplicity, so it's tangent and doesn't cross. So this is basically false. Okay. It was true that that was a 0, but that wasn't what they asked for. They want to know if it crosses over or if it's tangent, okay? All right, so one more and then we're doing a break. If P of X equals X minus 8 to the 5th, X plus 1 squared, then the graph is tangent at, oh, what's this point? 8. Oh, hold on. Oh, let me find it. Oh, my bad. -1, 0. So is that true or false? If P of X equals X minus 8 to the 5th, X plus 1 squared, then the graph is tangent at -1, 0. So we're looking at -1 came from that factor. The multiplicity is even. So it is definitely tangent. And they said it was tangent. We said it was tangent. So this one is definitely true. So you got to find which factor gave you that 0 and then look at its multiplicity. If it's odd, it crosses through. If it's even, it's tangent, okay? All right, y'all, so I'm gonna let y'all copy that. Let me go back so I can stop this video recording.